So this is College Algebra 1.3a, the first video of a couple for 1.3. Now this particular section should be very much a review for you. If you're at this point, you've taken intermediate algebra or elementary algebra, you've taken Algebra 2 in high school probably, and this whole linear function thing should be familiar. We're going to go over it. We're going to go over it pretty quickly, and hopefully it's something that you've done enough that you'll just be reminded of some of the things maybe you forgot over the years. Alright, so one of the things that's really important is whether or not the function we're talking about is a line, whether the picture of the equation is a line. And that's really all a graph is a picture of an equation. So if you look at the one that they give you on page 42, gives you h of x equals 0.224x plus 9.01. Now that is a linear function, and the reason I know it's a linear function is there's no exponent on the x other than the assumed 1. There's no exponent here except the assumed 1, and there's no fraction with the x or the h of x in the denominator position. Okay, so if that's the case, it's called a linear function, which means when you graph it, if you put in, let's say, your x and y tables, and you start listing numbers here and kicking out numbers here for your y or your h of x, and you start graphing, you're going to get a straight line every stinking time. Okay, so a linear function is a function that can be written as f of x equals ax plus b, with both the a and the b constants, meaning numbers. Doesn't really matter what numbers they are, but constants means they're not going to change. All right. So there are some things that are very necessary when you have an equation to put it in a format so that it's easy to graph, so that you don't have to always have an x and a y, take a number, plug it in for y, and have it give you a number. There's easier ways to do that, and we will get to the point slope form of the equation, just different things like that. So anyway, let's get started with example 1. Determine whether each equation represents a linear function. Alright, so look at A. It tells me that 0 equals 2t minus s plus 1. Can I put it in the form of f of x equals ax plus b? If I can, then it's a linear function. So let's set the equation equal to s. S equals 2t plus 1. Are 1 and 2 constants? Yes. Is it in the form ax plus b? Yes. So therefore it is a linear function. Now look at b. b says y equals 5. And now we have to figure out whether b is a linear function. So can we write it as y equals ax plus b? Sure we can. F of x, or y, equals 0x plus 5. Both this number and this number are constants. 0 times x is 0, so it cancels that, so you get f of x equals 5. So therefore it is a constant, or a linear function, and when we graph it, we get a graph that would look like this. Alright, because it looks like that, if we did the vertical line test and drew lines, yes, it'd only go through one point, so therefore we know it's a function through that method. So finally, let's look at C. We have x, y equals 2, so let's set that equal to y, and we get 2 over x. So remember what I said, it's a linear function if we can write it in the form of y equals ax plus b, and if the exponents on both the x and the y aren't there or are an assumed 1 there, and if neither x or y are in a denominator position. In this case it is, so it is not a linear function. Okay, so in this next section we're going to talk about intercepts. Now an intercept is where the line, the graph, crosses the xy axis. Okay, so in this case it's going to cross there and it's also going to cross there. So let's put some numbers on here. Alright, so it's crossing at 2 and it's crossing at -3. So the x-intercept is at 2. It's actually at 2, 0 if you want to say what point that is. And then this point is 0, -3. Now when you're talking about intercepts, you don't have to put the 0 there or the 0 there. You just say that the x-intercept is 2 and the y-intercept is -3. Okay, and that's pretty much all there is to an intercept. So how do you find these intercepts? Well, it's pretty simple. Let's look at example 2. 2x minus 3y equals 12. And really, in order to find the y-intercept, all we do is put a 0 in for the one we're not looking for, in this case the x. So 2 times 0 minus 3y equals 12. So that goes away. -3y equals 12. So y equals -4. That's where it crosses the y-axis at this point right here for this problem. Let's do it in yellow here. Okay. So see what happened there. When I put 0 in for x, it cancels everything out. We get rid of the x, and we're just looking for the y. The same is true when we're looking for the x-intercept. Let's use a different color here. 2x minus, and we're going to put 0 in for y this time since we're looking for x. So that gives me 2x equals 12, or x equals 6. And that's pretty much it for finding the intercept there. So one thing to remember here when you're dealing with linear equations or graphs of linear equations, you're going to have one y-intercept. The line is going to cross the y-axis one time, or it's going to cross, and it's going to cross the x-axis, unless, of course, the graph is a horizontal line. Then it won't cross the x-axis. Okay, and if it crosses just the x-axis and not the y-axis, it's not a function, so it's not a linear function, obviously. Okay, so follow with me example 3 on page 45. We've got this business property. It's purchased with a promise to pay off a $60,000 loan plus the $16,500 interest, giving us a total amount of $76,500 that has to be paid back when all is said and done. And you're going to do that by making 60 one-month payments, so that's 5 years, and you're going to be paying a payment of $1,275 a month. Okay, so that's what we're given. The amount of money Y is the amount of money remaining to be paid on $76,500 is reduced by $1,275 each month. So basically what they're saying is that every time we make a payment of $1,275, we're reducing the amount here that we're paying by $1,275. That's just common sense. All right, although the amount of money remaining to be paid changes every month, we can write a linear equation, and they give it to us there, that looks like this. Y equals minus 1275x, where x is the number of months. Okay, so let's look at this real quick. This says that if we pay $1,075 for, let's say, 3 months. We're going to multiply those two, and we're going to subtract that from 76,500. That will give us a y value, and that y value is the amount that we still owe. Okay, so that's all this is doing. How many months have we been paying the loan? 32. Plug that number in here, figure it out, and that will tell you how much more money you owe here. Alright, so that's an explanation of the problem. Now let's look at what they're asking us to do with it. A says find the x-intercept and the y-intercept. Well, we just went over that. In order to find the x-intercept, you put 0 in for y and solve. To find the y-intercept, you put 0 here and solve. Okay, so that's not too bad. Interpret the intercepts in the context of this problem situation. Well, you can look at B on the solutions and just read through that and get that. C, how should x and y be limited? Well, it only makes sense that since you're going from 0 to 60 months, you're limited there, which also limits your y value. Your y value can't be more than 76,500. You can't owe more than you owe. And it also can't be less than 0. Okay, so D, use the intercepts and results of part C and sketch the graph of the equation, and you can see the graph of the equation on page 46, bottom of the page. Alright, well, let's continue on here, and I'm going to go ahead and start a new video. So this is it for 1.3a.